What is uniform circular motion? Uniform circular motion is when an object moves in a circle at a constant speed. Typically, there are two main components acting on the object moving in circular motion: centripetal force and tangential velocity. Centripetal force is typically the net force on an object on a circular path that keeps the object moving on the path. This force can be generated by a variety of sources, such as tension in a string, friction between surfaces, or gravity, always directed towards the center of the circular motion with a constant magnitude. The tangential velocity represents the velocity tangent to the circular path. It is always perpendicular to the direction of centripetal force. When talking about rotational and especially circular motion, often the angle is the most important part. We can relate the angle in radians to the arc length on our circle. A full circle corresponds to 2 pi radians. Angular motion is often defined similarly to linear motion. Distance becomes angular distance, velocity becomes angular velocity, and acceleration becomes angular acceleration. The equation for the centripetal force is mass times acceleration. The acceleration is equal to v squared over r. Centripetal acceleration can also be defined as omega squared times r. Omega represents the angular velocity of the spinning object. Angular velocity describes the average velocity of a spinning object traveling in a circle to complete a full circular rotation. So omega is equal to 2 pi over t. 2 pi represents the 360 degrees in a circle, or the angular rotation, and t represents the period of rotation, or the time it takes to complete one full rotation. So the angular velocity would essentially be the change in angular distance over the change in time. But we can relate angular velocity to tangential velocity by multiplying omega by the radius r, because tangential velocity essentially is the average velocity of an object traveling a distance equal to the circumference of the circle, not the total angular rotation. So v equals omega times r, which is also equal to 2 pi r over t. We can then say that centripetal acceleration is equal to v squared over r, which is also equal to omega squared times r, which is then equal to 4 pi squared r times r over t squared. Circular motion concepts still apply when the motion is non-uniform. In that case, the acceleration and force is a vector sum of both centripetal and tangential components. Alright, now let's apply these to actual problems. You're welcome to pause the video after each question to try them out for yourself. Consider a 1,200 kilogram car turning on a flat road where F norm is equal to F grav in a circular curve of radius 250 meters. The coefficient of static friction between the tires and the road is 0.6. Determine the maximum speed the car can have before spinning out. Well, the only two forces in this question are centripetal force and friction. Assuming that centripetal force is the net force, the frictional force is equal to the centripetal force of the net force. So we can set v squared over r equal to static friction times F norm. We can convert this into static friction times mg. When you plug in the numbers, you can get 38 meters per second. In a rotor ride, passengers stand on the side of a circle which builds up to an angular speed of 45 rotations per minute. Once the speed is going steady, the floor is retracted and they're able to stick to the side. Determine the centripetal force on a 60 kilogram person in a rotor ride with a radius of 4.5 meters. What is the minimum coefficient of friction required to keep this person on the wall? For the first question, centripetal force is equal to mass times omega squared times r. Convert 45 rotations per minute into the right units, which is 4.71 radians per second. Plug the numbers to get 6,000 newtons. For B, there is gravity, normal force, and friction. Gravity always acts downwards. Friction always opposes motion when the people rub against the wall, so friction is the opposite direction of gravity. Since the people don't fall down, gravity is equal to the friction in magnitude. The normal force is equal to the centripetal force, which is the net force. Due to Newton's third law of motion, the people pressing against the side create a normal force perpendicular to the wall or towards the center. So F norm is equal to centripetal force. Force of friction is equal to static coefficient of friction times normal force, and force of friction is equal to force of gravity. This means that static coefficient of friction times centripetal force is equal to mg. Plug to get a coefficient of friction of 0.098. Consider the situation to the left, in which a block of mass 1 kilogram circles around the edge of a hoop of radius r equals 0.75 meters. The hoop has a coefficient of kinetic friction of 0.5. At a particular instant, the tangential velocity of the block is 5 meters per second. Determine the centripetal force of the hoop on the block, determine the frictional force of the hoop on the block, and determine the magnitude of the total force on the block. For the first question, centripetal force is equal to mv squared over r. Plug your values in to get 33.33 newtons. For the second question, the normal force is equal to the centripetal force as it is perpendicular to the hoop, so friction force is equal to the coefficient of kinetic friction times centripetal force. For the third question, we know that centripetal force is towards the center and frictional force is the tangential force. Using the Pythagorean theorem, we can find the total force vector.
Hope this video helps. If you found it useful, please like and subscribe to our channel for more helpful content. Stay tuned for more.